Technical mechanical engineers interview questions and answers. Want to crack your next mechanical engineer interview? Master these top technical questions that hiring managers love. Stay ahead of the competition with smart, confident answers that impress instantly. 1. What is the first law of thermodynamics? The first law of thermodynamics, also known as the law of energy conservation, states that energy cannot be created or destroyed, only transformed from one form to another. In a closed system, the total amount of energy remains constant. Mathematically, it is expressed as delta U equals Q, W, where delta U is the change in internal energy, Q is the heat added to the system, and W is the work done by the system. This law implies that any heat added to a system will either increase its internal energy or do external work. It's fundamental in understanding how engines, refrigerators, and even biological systems operate. The first law emphasizes that energy efficiency is about managing transfers and transformations, not creating energy from nothing. 2. How do you perform a failure analysis on a mechanical component? Failure analysis on a mechanical component involves a systematic investigation to determine the root cause of failure. The process starts with visual inspection to assess surface damage, fractures, or deformation. Next, data such as service history, operating conditions, and material specifications are collected. Non-destructive testing methods like X-ray, ultrasonic, or dye penetrant may be used to detect hidden flaws. After that, destructive tests such as hardness testing, tensile tests, and metallographic analysis can be performed to evaluate material properties. Fractography using scanning electron microscopy helps identify fracture mechanisms, like fatigue, overload, or corrosion. Once all data is analyzed, the failure mode and cause are identified. Finally, recommendations are made to prevent future failures, such as design changes, material upgrades, or improved maintenance procedures. This approach ensures reliability and safety in mechanical systems. 3. Explain the difference between strain and stress. Stress and strain are fundamental concepts in mechanics used to describe how materials respond to external forces. Stress is the internal resistance a material develops per unit area when subjected to a force. It is measured in units like pascals, Pa, and is calculated as stress equals force, area. Stress can be tensile, compressive, or shear depending on the direction of the applied force. Strain, on the other hand, measures the deformation or displacement a material undergoes due to stress. It is a dimensionless quantity, calculated as strain equals change in length, original length. Strain represents how much a material stretches, compresses, or shears. In simple terms, stress is the cause, force applied, and strain is the effect, deformation observed. Understanding both is essential for designing safe and reliable mechanical structures. 4. What is the function of a flywheel in an engine? A flywheel is a mechanical component used in engines to store rotational energy and maintain smooth engine operation. Its primary function is to regulate the engine's speed by minimizing fluctuations during the power strokes. In an internal combustion engine, the power is generated in pulses, which can cause uneven motion. The flywheel absorbs energy during the power stroke and releases it during the non-power strokes, ensuring continuous and balanced rotation of the crankshaft. It also aids in starting the engine by providing initial inertia and helps maintain momentum between cycles. Additionally, the flywheel connects to the clutch in manual transmission vehicles, playing a crucial role in engaging and disengaging the engine from the drivetrain. Overall, it enhances engine efficiency, reduces vibration, and contributes to a smoother driving experience. 5. How does a 4-stroke engine work? A 4-stroke engine operates through 4 distinct strokes: intake, compression, power, and exhaust to complete one combustion cycle. In the intake stroke, the piston moves downward, drawing in an air-fuel mixture through the intake valve. During the compression stroke, the piston moves upward, compressing the mixture for efficient combustion. In the power stroke, a spark plug ignites the compressed mixture, causing an explosion that forces the piston downward, generating mechanical power. Finally, in the exhaust stroke, the piston moves upward again, pushing burnt gases out through the exhaust valve. This entire cycle occurs over 2 revolutions of the crankshaft. The 4-stroke design provides better fuel efficiency, smoother operation, and cleaner emissions compared to 2-stroke engines. It's widely used in cars, motorcycles, and other internal combustion engine-powered machines. 6. What is the role of tolerance in engineering drawings? Tolerance in engineering drawings defines the permissible variation in a part's dimensions, ensuring that manufactured components function correctly despite minor deviations. It specifies the acceptable upper and lower limits for measurements, such as length, diameter, or angle. Tolerances are crucial because no manufacturing process can produce parts with absolute precision every time. By setting clear tolerance limits, engineers ensure that parts will fit and operate together without failure, even if slight differences exist. Proper tolerance selection balances functionality, cost, and manufacturability. Tight tolerances increase precision but also raise production costs. Engineering drawings use symbols and notation to indicate different types of tolerances, including dimensional, geometric, and surface finish. Ultimately, tolerances ensure product quality, reliability, and interchangeability, which are essential for mass production, assembly, and long-term performance of mechanical systems. 7. Explain the concept of fatigue in materials. Fatigue in materials refers to the progressive and localized structural damage that occurs when a material is subjected to repeated or cyclic loading over time. Even if the applied stresses are below the material's ultimate tensile strength, repeated stress can cause microscopic cracks to initiate and grow. Over thousands or millions of cycles, these cracks expand, eventually leading to sudden and unexpected failure. Fatigue is especially critical in components exposed to constant vibration, such as aircraft wings, bridges, or engine parts. Factors influencing fatigue include stress range, load frequency, surface finish, temperature, and material type. Engineers use SN curves, stress versus number of cycles, to predict a material's fatigue life. Designing against fatigue involves stress reduction, material selection, surface treatments, and regular inspections. Understanding fatigue is essential for ensuring the long-term reliability and safety of mechanical systems. 8. What is the difference between centrifugal and reciprocating pumps? Centrifugal and reciprocating pumps are two common types of pumps used to move fluids, but they operate on different principles. Centrifugal pumps use a rotating impeller to impart kinetic energy to the fluid, converting it into pressure energy. They are best suited for low-viscosity fluids and high flow rates, offering smooth and continuous flow. Centrifugal pumps are simpler, cost-effective, and require less maintenance, making them ideal for water supply, irrigation, and chemical processing. Reciprocating pumps, on the other hand, use a piston or plunger to displace fluid through a chamber. They deliver high pressure and are suitable for precise, low-flow applications. These pumps are often used in oil drilling, hydraulic systems, and industries requiring accurate dosing. While more complex and maintenance-intensive, reciprocating pumps provide consistent flow regardless of pressure variations. 9. Describe the working principle of a hydraulic system. A hydraulic system operates on Pascal's law, which states that pressure applied to a confined fluid is transmitted equally in all directions. The system uses an incompressible fluid, usually oil, to transfer force from one point to another. It typically consists of a pump, valves, actuators, like cylinders or motors, and fluid reservoirs. When the pump pushes fluid into the system, it creates pressure. This pressurized fluid flows through control valves to actuators, where it converts the fluid's pressure energy into mechanical force or motion. For example, when fluid enters a hydraulic cylinder, it pushes the piston, creating linear motion. Because fluid pressure is consistent throughout the system, even small input forces can be amplified to produce large output forces. Hydraulic systems are widely used in construction equipment, aircraft, and industrial machines for precise and powerful movement. 10. What is the importance of GD&T in mechanical design? Geometric dimensioning and tolerancing, GD&T, is crucial in mechanical design because it provides a precise and standardized way to communicate how parts should be manufactured and assembled. Unlike traditional dimensioning, GD&T defines not just size but also form, orientation, location, and runout tolerances. This ensures that parts will fit and function properly, even when made by different manufacturers or in different locations. GD&T improves quality control by reducing ambiguity and allowing for more accurate inspection. It also enhances design flexibility, enabling engineers to control the most critical features without over-constraining less important areas. This leads to cost savings in manufacturing and fewer errors during assembly. By using symbols and feature control frames, GD&T promotes a clear, concise, and universal language for engineers, machinists, and inspectors, improving communication across all stages of product development. 11. How would you select a material for high-temperature applications? Selecting a material for high-temperature applications involves careful consideration of several critical factors to ensure performance, safety, and longevity. The primary criterion is the material's ability to retain its mechanical properties, such as strength and hardness, at elevated temperatures. Materials like stainless steels, nickel-based superalloys, ceramics, and refractory metals are often chosen for such environments. Oxidation and corrosion resistance are also essential, as high temperatures can accelerate chemical degradation. Thermal conductivity, thermal expansion, and creep resistance must be evaluated to prevent deformation or failure over time. Additionally, the material should be compatible with other system components and the surrounding environment. Cost, availability, and manufacturability are also important considerations. Engineers often refer to material property charts, testing data, and standards to make an informed decision that balances performance with economic efficiency. 12. What is the difference between laminar and turbulent flow? Laminar and turbulent flow describe two different patterns of fluid motion. Laminar flow is smooth and orderly, where fluid particles move in parallel layers with minimal mixing. It typically occurs at low velocities and in fluids with high viscosity. In laminar flow, the velocity profile is parabolic, and there is little to no disruption between the layers, resulting in reduced energy loss and noise. Turbulent flow, in contrast, is chaotic and irregular, with fluid particles moving in random directions and creating eddies and vortices. It usually occurs at high velocities or with low viscosity fluids. Turbulent flow has a flatter velocity profile and increases energy loss due to internal friction and mixing. The Reynolds number helps predict the type of flow: laminar when below 2000, and turbulent when above 4000. Understanding both is vital in designing efficient fluid systems. 13. Explain the working of a heat exchanger. A heat exchanger is a device used to transfer heat between two or more fluids without mixing them. It works on the principle of thermal conduction and convection, allowing heat to flow from a hotter fluid to a cooler one. Common types include shell and tube, plate, and air-cooled heat exchangers. In a shell and tube design, one fluid flows through tubes while another flows around them in a shell, exchanging heat across the tube walls. In plate heat exchangers, thin metal plates increase the surface area for efficient heat transfer. Heat exchangers are widely used in industries like power generation, HVAC, automotive, and chemical processing. They improve energy efficiency by recovering waste heat or preheating fluids. Proper design ensures maximum heat transfer, low pressure drop, and long-term reliability, making heat exchangers essential for thermal management in engineering systems. 14. What are the different types of bearings and their uses? Bearings are mechanical components used to reduce friction between moving parts and support loads. There are several types of bearings, each suited to specific applications. Ball bearings use balls to minimize friction and are ideal for light to moderate loads. Commonly found in electric motors, fans, and wheels. Roller bearings use cylindrical rollers to handle heavier radial loads. Used in conveyor belt rollers and gearboxes. Tapered roller bearings handle both radial and axial loads. Widely used in vehicle axles and machine tool spindles. Needle bearings contain long, thin rollers, ideal for compact spaces with high load capacity. Thrust bearings, designed to handle axial loads. Used in automotive applications and rotating shafts. Plain bearings, simple, low-cost bearings with sliding motion, used in door hinges and machinery joints. 15. How do you calculate the efficiency of a machine? The efficiency of a machine is calculated by comparing the useful output energy or work to the total input energy or work, typically expressed as a percentage. The basic formula is efficiency, percent, equals useful output, total input, times 100. For example, if a machine uses 500 joules of energy to perform 400 joules of useful work, the efficiency would be 400 500ths times 100 equals 80%. Efficiency indicates how well a machine converts input energy into useful work. No real machine is 100% efficient due to energy losses from friction, heat, or sound. Improving efficiency often involves reducing these losses through better design, lubrication, or material selection. Engineers use efficiency to assess machine performance, compare alternatives, and identify opportunities for optimization, especially in systems like engines, motors, and turbines. 16. Describe the process of welding and its types. Welding is a fabrication process that joins materials, typically metals or thermoplastics, by applying heat, pressure, or both to melt and fuse parts together. The process may or may not use filler material to strengthen the joint. There are several types of welding, each suited to specific applications. Arc welding uses an electric arc to generate heat. Includes methods like MIG, metal inert gas, and TIG, tungsten inert gas, welding. Gas welding uses a flame produced by burning gas, like oxyacetylene, to melt the base metal. Resistance welding involves passing electric current through the metal to generate heat at the joint. Laser and ultrasonic welding, used for precision welding in electronics or medical devices. Each type offers specific advantages in terms of strength, speed, and precision. 17. What is the difference between static and dynamic loading? Static and dynamic loading refer to different types of forces applied to a structure or material. Static loading involves forces that are applied slowly and remain constant or change very gradually over time. Examples include the weight of a building, furniture on a floor, or a bridge's own weight. These loads do not cause rapid motion or vibration, allowing for predictable stress distribution. Dynamic loading, on the other hand, involves forces that vary rapidly with time and may include motion, impact, or vibration. Examples include vehicles moving over a bridge, wind gusts, or seismic activity. Dynamic loads can cause fatigue, resonance, and additional stresses due to acceleration or momentum. Designing for dynamic loads requires more complex analysis to ensure safety and durability. Understanding the difference is essential for creating reliable and efficient mechanical and structural systems. 18. What is the purpose of a pressure relief valve? A pressure relief valve is a safety device designed to protect equipment and systems from excessive pressure buildup. Its primary purpose is to automatically release fluid, gas, or liquid when the internal pressure exceeds a preset limit, preventing potential damage, explosion, or failure. Pressure can rise due to factors like thermal expansion, blocked flow, or equipment malfunction. The valve opens at the set pressure, allowing excess fluid to escape and reducing the pressure back to safe levels. Once normal conditions are restored, the valve closes again to maintain system integrity. Pressure relief valves are essential in boilers, pipelines, chemical plants, compressors, and hydraulic systems. They ensure compliance with safety regulations and protect both machinery and personnel. Proper selection, installation, and maintenance of these valves are critical to ensuring reliable and safe operation in any pressurized system. 19. How do you ensure the safety of mechanical systems? Ensuring the safety of mechanical systems involves a combination of design, maintenance, testing, and monitoring practices. The process starts with using reliable design standards and material selection suitable for operating conditions like load, temperature, and pressure. Safety features such as guards, emergency shutoffs, and pressure relief valves are integrated to protect users and equipment. Regular maintenance is essential to identify and fix wear, corrosion, or misalignment issues before they lead to failure. Inspections and testing, such as non-destructive testing, NDT, verify the integrity of components. Engineers also use fail-safe design principles to ensure systems behave predictably under failure. Proper training for operators and clear safety protocols help minimize human error. Compliance with safety regulations and standards, like ISO or OSHA, further ensures systems are reliable, efficient, and safe for operation. 20. Why should we hire you as a mechanical engineer? You should hire me as a mechanical engineer because I bring a strong combination of technical knowledge, practical experience, and a proactive attitude. I have a solid foundation in core engineering principles such as mechanics, thermodynamics, and materials science, along with hands-on experience in CAD design, simulations, and project management. I excel at solving complex problems, working collaboratively in team environments, and meeting project deadlines with efficiency and precision. My ability to adapt quickly, continuously learn, and stay updated with industry trends allows me to contribute innovative ideas and improve system performance. I am passionate about engineering and committed to delivering high-quality work that meets both technical and safety standards. My strong communication skills also enable me to clearly convey technical concepts, making me a valuable asset to cross-functional teams and engineering projects. Like these questions? Hit subscribe for more engineering interview help. Share this video with fellow engineers and ace your next interview with confidence and technical brilliance.